Hi there. In this video, I'm going to talk a bit about what calculus is and about what calculus class is. Maybe you're going to be taking calculus, or you're thinking about taking calculus, or you've been told that you should take calculus, or maybe you have a friend or a family member who's taking calculus and you're wondering what that involves, what's that all about? So that's what I'm going to be talking about in this video. So let's say you want to know what calculus is all about, so you pull out a dictionary and you look up, let's see, calcium, calculus, there it is, calculus. A method of computation or calculation. Well, there's three different definitions. I think it's the second one, but that's not all that helpful. A branch of higher mathematics comprising differential and integral calculus. Well, if I knew what calculus was, I wouldn't be looking it up. So what's up with that? So then maybe you turn to your college catalog, where it lists all the classes that the college offers with a brief description of each one, and you find something like this. And you think, oh, well, there's a calculus 1 and a calculus 2 and a calculus 3. So it looks like calculus is a trilogy, like Lord of the Rings or Back to the Future. And maybe you look around a bit more in the catalog and you also find something called business calculus or calculus for social scientists or applied calculus. And you think, well, there's all these different calculus classes. What's going on with that? What's the difference? And which one should I be focusing on? So some of the questions I'm going to try to answer in this video, and I'm not going to answer them completely, but I'm going to try to give some idea of the answer, give just a beginning of an answer to questions like, what is calculus anyway? Where did calculus come from? What's up with all the different calculus classes? And what students always want to know when they're going to be taking calculus, is calculus hard? So we could turn to Wikipedia, and that's actually not a bad idea to look up on Wikipedia what it says about calculus. And it says, calculus, originally called infinitesimal calculus or the calculus of infinitesimals, is the mathematical study of continuous change in the same way that geometry is the study of shape, and algebra is the study of generalizations of arithmetic operations, and blah, blah, blah. It goes on to talk about some other things, some of which I'll mention later on in this video. But focus on that. Calculus is the mathematical study of continuous change. In fact, I've seen lots of calculus textbooks that pretty much start out by saying something like, calculus is the study of change and motion. Now, in a way, that's a pretty good description. That's a pretty good explanation of what calculus is about, but it's describing calculus by telling you what calculus is used for instead of really telling you what calculus is. So that's sort of like if I tried to tell you what a screwdriver is by saying, oh, it's something that you use to screw and unscrew screws. Well, I could take a butter knife and use that to unscrew or untighten a screw. Would that make it a screwdriver? On the other hand, if I took this and used it to do something that didn't have anything to do with screws, like prying open the lid of a paint can, would it still be a screwdriver? And it would be possible to present all the mathematical content of a calculus class without ever referring to anything changing or moving. It might be kind of pointless and weird, but you could do it. So in a way, that's what calculus is typically used for, but it's not entirely what calculus is. Another way I could explain it, and I've seen calculus books that present it this way, is that calculus is based on the idea of limits. And that's what makes the difference between all the math that you learned before calculus and the math that actually is calculus. Everything that actually is calculus is based on the idea of limits. Now, I'm not expecting you to know what limits are at this point if you haven't actually studied calculus. I'm just saying, well, if you do study calculus, a typical calculus class we'll start fairly early on talking about limits and what they are and how they're defined and how to find them and that sort of thing. And then all the other main concepts that you study after that are defined in terms of limits. So calculus is all the things that are defined in terms of limits. So again, that's a pretty good description, but it's not perfect. And one thing that's wrong with it is that if you go back and look at the history of calculus, when calculus was first discovered or developed, those other concepts came along first before anybody thought of them in terms of limits. It was only a little while later, a couple generations later, that people went back and redefined or reformulated things in terms of limits to put things on a firmer theoretical foundation. And so you could give at least a intuitive description of those other concepts without ever referring to limits. And it is possible, although it does get complicated, to formally define and describe everything in different ways that don't have anything to do with limits. So, in a way, calculus it's based on the idea of limits, but it doesn't have to be. Another way of describing the difference between algebra, or the math that comes before calculus, and calculus itself is by thinking about the difference between straight lines and curves. If everything was a straight line, and every function was a linear function, we wouldn't need calculus. We would be able to figure out everything there was to know just by using basic algebra. And straight lines include things like the sides of a triangle, or a square, or a polygon, a pentagon, or a hexagon, or something like that. But notice, as something like that has more and more sides to it, it's looking more and more like a circle. So if you had something with 20 sides that are all straight line segments, but there are a lot of them, it's looking a lot like a circle with completely round sides. So in a way, you could think of a circle with its curved sides as being made up of infinitely many straight line segments. A circle is sort of like an infinite-sided polygon. And in a way, many of the basic concepts of calculus are based on the idea of treating a curve, a curved figure, as if that curve were made up of infinitely many pieces that were straight line segments. And they would have to all be infinitely small. And if you're thinking, well, that doesn't make much sense, what does that mean? You're right, it doesn't really make much sense, but calculus is a way of formulating that in a way that it does make sense, and you can actually work with that and do things with it. Another thing you could say about the difference between algebra and calculus is that where algebra is all about equations and numbers being equal to something, calculus is about being close to something. I had a math teacher in high school that liked to describe calculus like this, by saying that calculus was all about close to. So in calculus, you talk about what happens when something is really, really close to some number. Why is that an important distinction? Well, imagine you've got a curve, and you have a point on the curve, and then you find another point that's really, really close to that first point. It's not equal to it, it's just really close to it. So then you can go from that first point to the other point that's close to it, and you can draw a line between them. And then you can talk about things like what direction that line is going, what's the slope of that line. Now you couldn't do that if the second point was equal to the first point. Then they'd be right on top of one another, and you couldn't specify a direction or anything like that. But as long as the second point is only very, very close to the first point, then you can talk about the direction from one point to the other. And in a way, some of the ideas of calculus are based on the idea of, well, you can take a point and then another point that's infinitely close to that first point, but not equal to it. And again, that's the kind of thing that you might think, well, that doesn't really make sense. How can it be infinitely close without being equal? And again, calculus is a way of formulating that in a way that it actually does make sense, and you can actually work with it and do things with it. We saw earlier when we looked in the dictionary and also when you looked at Wikipedia that there are two sort of main ideas or branches or subjects or parts to what is typically known as calculus. There's differential calculus and there's integral calculus. So if you take a calculus class, you'll spend a lot of time on differential calculus and you'll spend a bunch of time on integral calculus. So differential calculus is about the idea of derivatives and finding derivatives, which is known as differentiation. Now, I'm not going to explain here what that is. You'd have to take calculus or at least spend a lot more time talking about what that is to really understand what derivatives are. But that's what the part of calculus known as differential calculus is all about. It's all about derivatives, which represent rates of change, or geometrically, they represent the slope of a straight line that is tangent to a curve at a particular point. Then the second main idea, integral calculus, is about integrals and integration, which is the process of finding integrals. And they geometrically represent the area under a curve, between that curve and like the x-axis. And then what's called the fundamental theorem of calculus ties these two ideas together and shows how they are related to one another. Basically, integrals are sort of the reverse of derivatives. Another way you could describe calculus is the study of functions. If you actually took a calculus class, you might come out of it thinking, oh, we spent a lot of time talking about functions. Pretty much every day we said, here's a function, and we did calculus kinds of things with that function. We said, what's the derivative of the function? What's the integral of the function? What's the limit of the function? Where does the function have a maximum or a minimum? This and that and the other about functions. And so again, that's not entirely accurate. You probably learned something about functions before you got to calculus. And there are some parts of calculus that aren't, strictly speaking, function-centered. But that's not a bad way to think of what calculus is all about. It's about studying functions and figuring out what you can do with them and learn about them and analyze them in various ways. So, for example, given a particular function, y equals f of x, it might be 3x squared plus 10. It might be the square root of x. It might be x plus 1 divided by x minus 2. It might be the cosine of x. But given a function, we might want to investigate questions like, where does the graph of that function go up and where does it go down? And how steeply does it go up or down? And that tells us about when the function is increasing or decreasing. We might want to know, are there any high or low points on the graph of the function? And if so, where? And that tells us about where the function would have a maximum or minimum value. Are there places where the function is undefined? Are there holes or jumps in the graph? And if so, what happens close to those places? What happens as we go off to the right or to the left? That is, as the x that you're plugging in gets really, really large, or maybe really, really small. And how big is the area enclosed by the graph, or between the graph and the x-axis? So those are all examples of things that we would study using the techniques of calculus. And if that all seems pretty abstract, why would you want to know that about a function? Well, if the function actually stood for something in particular, like, say, velocity. Say you've got a moving object, and it's not necessarily moving at the same speed all the time. Maybe it's getting faster or slower. So its velocity might be changing over time, but you can think of the velocity as a function of time. So you've got a function that tells you how fast you're going at any given time. And then you might want to ask, at any given moment in time, that is for any particular x, are we speeding up or slowing down? Are we accelerating or decelerating, and how fast? That is, how is our velocity changing at that moment? At what moment are we going the fastest or the slowest? What is our maximum or minimum velocity? As time goes on, what happens? Does our velocity level off? Are we dying out and coming to a stop? Are we just going to get faster and faster and faster? What happens in the long run? And over a given period of time, how much distance have we covered? If we know how fast we were going, for how long, can we work out how far we've gone? So those are examples of the kinds of questions that we can investigate using calculus. Now, I said that one of the questions I'd be addressing is, where did calculus come from? Well, there are two guys who split the credit for inventing calculus. One of them was the Englishman Isaac Newton, who was not only a great mathematician, but also a great scientist, a physicist. And if you've taken a physics class, you've probably studied Newton's laws of motion and his way of describing how gravity works and things like that. And so that was connected to his study of calculus. You might say he invented calculus to allow him to study the properties of motion and how things move and what governs orbits of planets and things like that. The other person who invented calculus at pretty much the same time was the German philosopher and historian and philologist and lawyer, and he did a bunch of things. If they'd had computers in his day, he might have been a computer scientist. But Gottfried Wilhelm Leibniz, he also developed the ideas behind calculus. And for a long time, there was this big conflict and debate over which one of these guys invented calculus first, and did one of them steal it from the other one? And nowadays, it's pretty well recognized that they both deserve credit. They both came up with the ideas for calculus pretty much independently of one another. Newton was probably first to develop the ideas, but he didn't publish them. He kept them private. And so when Leibniz published his calculus, it looked like, well, did he steal it from Newton? Did he have some inside information? Was it something he came up with on his own? So like I said, nowadays, they both kind of split the credit. They both came up with calculus simultaneously. And when I say that Newton and Leibniz invented calculus, I don't mean that they are responsible for everything that you'll find in a calculus textbook. There were lots of mathematicians who came before them who established the background and anticipated the ideas that calculus is based on. And there were many mathematicians of later generations who refined and reformulated and developed and expanded on and found new applications for the basic ideas of calculus. So I'm definitely not going to give a detailed history of calculus in this video. That would take way too long. But if I were going to give a detailed history of calculus, it would go all the way back to Archimedes, who was one of the ancient Greeks and lived back in the 200s BC, and was maybe the first person to think of the idea of thinking of a circle as made up of infinitely many straight line segments kind of thing. And it would go as far forward, at least, as the 1960s. Now, I mentioned earlier that you might find two versions of calculus if you look through a college catalog. You might even find more than that, but it's fairly common in US colleges and universities to have what's called the calculus sequence, which is usually made up of 3 classes called Calculus 1, Calculus 2, and Calculus 3, or maybe Calculus and Analytic Geometry 1, 2, and 3. And then also to have something called Business Calculus, or Calculus for Social Science, or something like that. So what's the difference? Well, for one thing, the Calculus 1, 2, 3 sequence is what you would be taking if you're going to be majoring in either mathematics itself or a heavy math-related field like physics or engineering. And in that case, you would probably be taking all 3 of those classes, but other people are fine just taking 1 or 2 of them. Some people only take Calculus 1, some people only take Calculus 1 and 2 but don't go on to 3, and some people take all 3. There aren't really any cliffhangers from one class to the next, and if you take just the first semester, just Calculus 1, you do get a pretty good exposure to most of the basic ideas of calculus. But if you do take all 3, you will be taking them in order. You should take Calculus 1 before Calculus 2 and Calculus 2 before Calculus 3. And you would probably use the same big 1,000-page calculus textbook for all 3 classes. So it would take you 3 semesters to get through most or all of the material in a commonly used calculus textbook. And by the way, maybe you can see on here it says Calculus Early Transcendental Functions. If you're wondering what that means, that just has to do with the way the topics are ordered in a book like this. So some calculus textbooks and some calculus classes introduce the ideas of calculus first on so-called algebraic functions, functions that are built up with addition and multiplication and division and roots and things like that, and then save for later applying them to the so-called transcendental functions, things like the trigonometric functions, sine and cosine, and exponential functions like e to the x, and logarithmic functions. Those are the transcendental functions that this refers to. And so when it says early transcendental functions, that just means it introduces those fairly early on and does calculus things with those, along with doing calculus things with maybe simpler or more straightforward algebraic functions. Now, the exact way that topics are divided up among those 3 courses can vary depending on where you take them and maybe even from year to year as they get reorganized. But it's fairly common for Calculus 1 to give you a thorough grounding in derivatives and at least a solid introduction to integrals. Calculus 2 might go more into more advanced integration techniques and cover infinite series and maybe a few other topics. And then Calculus 3 is where you go into 3D and you deal with functions with more than one variable and 3-dimensional curves and surfaces and vectors and things like that. Now, if you are majoring in something like business or economics or something like that, then instead of taking Calculus 1, 2, and 3, or just Calculus 1, you might take a version of calculus that's specifically devoted to the needs of people like you. So what's the difference? Well, for the calculus sequence, there are more STEM-related applications, and here STEM, of course, stands for science, technology, engineering, and mathematics. The trigonometric functions like sine and cosine and tangent and their inverses are included. You do work with those. There are usually more theoretical details given. You learn about the precise mathematical definitions of things. You might see some theorems and proofs. And it prepares you to go on. So if you've taken Calculus 1 and 2 and 3, that's not the end. That prepares you to go on to take other classes like differential equations or real analysis or complex analysis, which explore some of the same ideas of calculus but with complex numbers. On the other hand, a business calculus type of class is going to have more business and economics related applications. And yes, calculus is used in those areas. It typically does not include the trigonometric functions. So you don't need to have studied any trigonometry to take business calculus. That doesn't come up in the things that are covered there. And you will usually get less of the theory, the theoretical math behind the calculus. And one last question. Is calculus hard? Well, a number of years ago, I happened to be reading a message board discussion in which people were answering this question. Somebody asked, hey, is calculus hard? And some of the responses that people gave to that question were, if you breeze through algebra and trig, you'll probably breeze through calc. If you suffered through the former two, you'll probably suffer as much or more through calc. I think the concepts behind calculus are easy, but they are different from the math you've had up until that point, so it takes a while to get used to it. Calculus involves a few conceptual leaps up from just standard algebra and trigonometry, while requiring that you have those skills down absolutely flat. And for many people, calculus is not hard at all, but you'll make so many mistakes because of algebra, not calculus. So, is calculus hard? Well, it is a fairly advanced class that depends on and builds on and goes beyond things like algebra and trigonometry. Whether you find it hard would depend on things like how good of a teacher you have, how good they are at explaining things, and how hard they choose to make the class, how strong your math background is, and how thoroughly you've mastered the mathematical skills that you need going into calculus, how quickly you pick up on new ideas, how much time and effort you spend on studying calculus and practicing and working problems and that sort of thing. So, yeah, it can be hard, but hopefully it isn't that bad. So, that's my introduction to calculus. This is the kind of thing that I would be talking about if you were taking a calculus class for me. On the first day of the class, I'd be talking about, okay, here's what we're going to be doing, here's what to expect, here's what this calculus class is like. Hope this was helpful. If you have any other questions, send me a message or leave a comment. Thanks for watching.